Welcome back. For this session, for this video, we're going to be talking about troubleshooting BGP neighbor adjacencies. BGP is a complex routing protocol, and there are quite some things that could possibly go wrong. Besides being complex, it's also completely different compared to other IGPs. In this lesson, we'll start with troubleshooting BGP neighbor adjacencies. Once the neighbor adjacencies is working, you can focus on troubleshooting missing route advertisements. Key to troubleshooting BGP is understanding how BGP forms a neighbor adjacency. If you are unsure how this process works exactly, you might want to check an older lesson. Having said that, let's look at the scenario. Alright, let's copy this diagram over to GNS3. Say, I think we're at 11. Alright. Turn them on, connect a console to each of them, and where'd it go? Oh, there it is. Okay, alright. For router 1, we're going to configure the 0/0 interface. 0/0 IP address 192.168.12.1, subnet mask of /24, no shut. Configure the loopback interface 0 with an IP address of 1.1.1.1 because it can't be 0. Then a /24. I'll configure BGP, router BGP with autonomous system number 1. We're going to do neighbor 92.168.12.2 remote AS2. Alright, and I'll configure router 2. Interface FA0/0. And we'll give it an IP address of 192.168.12.2 with a subnet mask of /24. No shut this interface, and we'll configure a loopback interface. Interface LO0 with an IP address of 2.2.2.2 and subnet mask of /24. What else? Okay, we gotta configure the BGP with autonomous system number 2. Network 192.168.12.1 remote AS. Okay, why is it not working? Network. Oh, sorry, neighbor 192.168.12.1 remote AS 1. Cool. Alright. BGP. Nothing is up yet. Yep, there it is. IP BGP route. IP route. Oh, we're not going to see anything yet because the IPs on the loopback interfaces aren't being advertised yet. So, yeah. Yep. It's receiving no prefixes because nothing is being advertised. Alright, when two external BGP routers that are directly connected do not form a working BGP neighbor adjacency, there are a number of things that could go wrong. So layer 2 could be down, layer 3 could have an issue with the wrong IP addresses. There could be a access list that's blocking port TCP 179. There could be a wrong IP address configured on the neighbor router. The IP addresses that were used for neighbor adjacency look okay, or so something else might be the issue. Let's try a ping. I think his setup might be different than mine because mine should be able to ping. I mean, yeah, BGP doesn't even need to be up for me to be able to ping this address of router 2. Alright, so what he's doing is he's checking out the IP interfaces on R1, which is up, and on R2 it looks like it's in shutdown state, so it'll say administratively down. He fixes it by turning on the interface, and the neighborhood relationship comes up. That's what we like to see. Our BGP neighbor adjacency is established. Lesson learned. Make sure your interfaces are up and running. BGP requirements. Alright, so we have, I think it's the same exact diagram or topology from the last one, so you don't have to do anything here. Same topology, but another issue. The goal in this scenario is to establish the external BGP neighbor adjacency between the IP addresses and the loopback interfaces. Okay, so it looks like he's specifying the neighbor of 2.2.2.2 as remote AS2, so I gotta remove some of the configurations that's currently there right now. Or maybe I don't have to. Maybe it'll be fine. Alright. So router BGP 1, and I'll put in neighbor 2.2.2.2 remote AS2. No auto summary. Wait, it's already a no auto summary by default. Okay, on R2, get into the router configurations, which we already are, and we'll input the line neighbor 1.1.1 with remote autonomous system number 1. Yeah, there is no BGP neighborhood or neighbor adjacency because those two networks aren't advertised yet. So R1 has no route to reach 2.2.2.2. So in this case, I believe what needs to happen is learn it in another lesson. Wait, actually, is it multi-hop that fixes it? Well, there's one method to solve this issue is to put a static route on R1, and that static route will say to reach 2.2.2/24, you'll go through 192.168.12.2, which is this interface, and so that would allow R1 to even start trying to establish a BGP neighborhood relationship with R2 on this IP address, but it's not going to work because the TTL will be at 1 and it'll get discarded before it'll even reach the loopback interface. So the solution, one solution, I don't know what he's actually gonna tell us to do, but one solution is to use a static route and then to use BGP multi-hop to set the TTL to 2 so that it can actually reach this interface. Both routers show their BGP neighbor as idle. There are two number of things we can check here. The IP address of the BGP neighbor is the IP address of the BGP neighbor reachable. We are not using the directly connected links, so we might have routing issues. The TTL of an IP packet that we use for external BGP is 1. This works for directly connected networks, but not if it's not directly connected, we'll need to change this behavior. By default, BGP will source its updates from the IP address that is closest to the BGP neighbor. In our example, that's the fast Ethernet interface. This is something we'll have to change. So I suppose what also needs to happen is using BGP next hop itself, possibly. Alright, so right. Both routers only know both routers only know about their directly connected networks. In order to reach the other's loopback interface, we'll have to use static routing. Alright, so let's do that. IP route 2.2.2, and but if I use the no, that's fine. Actually, I think it should be fine. Yeah. 92.168.12.2, and over here we'll have IP route 1, 2.5. That's not where I want to be. IP route 1.1/32, 92.168.12.1. Okay. So R1 should be able to ping 2.2.2. 2.2.2 right now. Yep, and then we'll configure multi-hop. See, router BGP1, neighbor 2.2.2.2, eBGP multi-hop 2. And if we go back here, router BGP2, neighbor 1.1.1, BGP multi-hop 2. Oh, it wants me to use debug at router 2, so debug IP BGP. exactly getting the same messages. Okay. Okay, it's because it's going to see it coming from 192.168.12.2. Alright, in that case, router BGP 2, neighbor 101.101, update source, loop back 0, and go back to R1, neighbor 2.2.2, update source, loop back 0. Over here, it looks like we were able to get it to establish state. And right now, show IP BGP summary. Is that the one I want? Yep, looks good. BGP routers don't have to establish a neighbor adjacency using the directly connected interfaces. Make sure the BGP routers can reach each other, that BGP packets are sourced from the correct interface, and in case of eBGP, don't forget to use the multi-hop command. Alright, gonna take a short break. Alright, I'm back. Let's see. Alright, the next topic we have is BGP Tcp Port Filtering. Alright, let's take a look at internal BGP issue. Looks like I will have to create some more nodes. I'll connect them with fast Ethernet 0/0. Let's do a snippet. Save as, I think we're at number 12. Alright. Let's power these guys on. Open up a terminal window. FA00, IP address 192.168.12.1/24 mass. I'll shut down. Router BGP1 neighbor 92.168.12.2 with a subnet mask of /24. Wait, what am I doing? To remote AS 1. Yeah. Alright, cool. Let's move to R4. T. Int FA 0/0 IP address 192.168.12.2 /24 subnet mask. Shut. Configure BGP with autonomous system number 1. Specify the neighbor 192.168.12.1 with a remote autonomous system number of 1, which makes it an iBGP neighbor. Alright, cool. Yeah. What else? Alright, that's it. Looks like the BGP connection is up. Show IP BGP summary. There it is, just like it's written here. Wait, why is it not becoming neighbors? What's wrong? I mean, it worked for me, but it's not working for him. I think he did everything fine. It's probably because he misconfigured the IP addresses on the interfaces, or because the topic is TCP port filtering. That might be the problem too. So he blocked it without telling us how, and we're not going to be able to follow along in that case. Alright, so in this snippet, he's pinging it, and ping will be a success because ping does not use TCP. Alright, looks like he's testing layer 4 with telnet. Can I do that? 68.12.2. Password required, but none is set. Oh, he's doing it to port 179. Oops. Alright, I'm unable to connect to TCP port 179 from both routers. This should ring a bell. Maybe something is blocking BGP. It looks like on R2, in his configurations, there's a inbound access list, which denies BGP. Someone decided it was a good idea to secure a BGP and block it with an access list. Let's get rid of it. Alright, so he's going to remove the access list from interface 0/0, and looks like the neighborhood relationship does turn up. The lesson learned here is to not block port 179 in access lists. Here we have another topology that is similar to the first one we used. Or actually, it's not, because the first one we used has 2 different autonomous system numbers. So it's an expansion of this one. So instead of copying this diagram over here, we're gonna just do the configurations. Alright, so interface loopback 0, IP address 101.1.1, the /24 subnet mask. Oh, it's already up. Oops. Oops. Paste loopback 0. IP address 2.2.2.2/24. BGP 1, neighbor 101, remote AS 1. Okay, go back to R3. BGP 1 with a neighbor of 2.2.2.2, remote time system number 1, be an iBGP connection. Show IP BGP summary. It's in active state. So he's looking at the routing table now, and he sees that 2.2.2 network is not listed anywhere in R1. And the similar thing goes with R2, where 1.1.1.0 is not a network in router 2's routing table. And looks like he has some OSPF configured. But I'm thinking he didn't redistribute the routed to BGP, so it might not work. It'll still be active. A debug shows up that the connection is refused, and it also shows us the local IP addresses that is used for BGP. Seems like someone forgot to add the update source command, so let's fix it. Okay. It looks like that fixed the issue. Huh. No, wait, you don't need to redistribute the path. It's already, because they're already both participating in OSPF. That makes sense. So this is another issue that is fixed by the update source command. Nothing new. So lesson learned. It's common practice to configure iBGP between loopback interfaces. Make sure these loopbacks are reachable and that the BGP updates are sourced from the loopback interface. These are the most common issues as to why BGP doesn't form neighbor adjacency. The routers are now up and running, so we can continue to troubleshoot missing route advertisements. And I suppose that's the next lesson. I am going to close off the stream and start a new one for the next lesson.